This tutorial looks at applications of right-angled triangles. By the end of this presentation, you should know some techniques to help you solve application-style questions. This is a pretty hard concept that people often struggle with. Getting questions out of worded sentences is a skill, and you really just need to practice it. In order to be able to do it. There is some things to help you though, and those techniques are what we're looking at here. So how to start: highlight using different colors. So different colors can represent different areas of a question. I always use a certain color to represent what I'm trying to find in a question. So the question actually asks me to find a length or find an angle or find etc. Then that is what I'm going to highlight in a different color. And also highlighting the accuracy. So what units do I need to have my answer in? Do I need to do a conversion? And how accurate do I need to be? Are we talking 2 significant figures or 3 decimal points, or how accurate do I need to be? So highlight using multiple colors is always a good way to start. You can then also draw a diagram. So if possible, draw a diagram to represent the situation. Especially in trigonometry, there's normally a way you can draw a diagram for trigonometry. And then after you've drawn a diagram, write down any formulas you may need. So you've drawn a diagram and you've realized you need to use the sine ratio. You would write down the general sine theta equals opposite over hypotenuse ratio. Please note this bottom point. Do not round until the very end calculation. So if you're doing a calculation or multiple calculations where you're using prior working, you need to use exact values, no rounding, until the very end. So the only time you round in a calculation is when you're actually red boxing an answer on the page. Your calculator will store enough accuracy that you can use your calculations on your calculator by, I suppose, copy and pasting on your calculator. So there's no excuses for just typing 2.3 when you're meaning 2.3 reoccurring, because your calculator will store it as that value. So don't do that. That will give you rounding error in your answer if you do that. All right, so examples. Example 1, a flagpole casts a shadow 7.42 meters long. So highlighting that as my first piece of information. Different piece of information is that the sun's rays makes an angle of 38 degrees with the level ground. So level ground, horizontal line basically. We're asked to find the height of the flagpole and correct the 2 decimal places. So height of the flagpole is the answer that I'm after, and my units is 2 decimal places. My very first step, after having done already my highlighting, is to draw a diagram for this scenario. So drawing a diagram, I've put in a pretty sun. Look, where possible, just draw a right angled triangle. Don't draw pretty pictures. You're going to distract from what actually you need to get done for each question. So it's a right angle triangle. I'm going to put in the units that I have, or the measurements that I have. So 7.42 meters. Note that I've written units there. That's the units that my end answer will have to have. So the height of the flagpole will be in meters. 7.42 is the length of the shadow. So that's from the bottom of the flagpole to the end of the shadow. And then the angle of 38 degrees with the level ground. So the ground and then up on my imaginary line that heads to the top of my flagpole is 38 degrees. Label the sides of my triangle. So I've got X is my opposite, 7.42 is my adjacent, and then we know because of our trigonometric ratios that the ratio we're going to have to use is TOA, which is tangent. So tan theta is equal to O over A, and then we can substitute in what we know. Tan 38 is equal to X divided by 7.42. We're after finding X, so we're going to multiply both sides by 7.42, and then this calculation is something I put into my calculator. Make sure you check that your calculator is in degrees, which mine is, And doing this, I need my answer to 2 decimal places. So 5.797. It's going to round it up to 5.80, sorry. Make sure you put the 0 in because that's telling us we're correct to 2 decimal places. So it does have meaning. And then units attached to that as well. This is a worded question. So worded questions needs worded answer. So the flagpole is 5.8 meters tall is your end answer. Example 2. Alright, the sloping roof uses sheets of corrugated iron, 4.2 meters long, on a shed 4 meters wide. There's no overlap on the roof past the sides of the wall. Find the angle that the roof makes with the horizontal correct to 1 decimal place. We've already got a diagram here, so I suppose our first major hurdle is already done for us. What we're after finding is that the angle the roof makes with the horizontal. That's this angle in here. This is our horizontal. The angle in here is the one that the roof makes. So identifying that as theta, labeling our sides, and then recognizing what we can use. Now I'm going to use A and H because that's where I've got lengths. I don't have my opposite length, so I'm not going to use it. So cos is the trigonometric ratio that I'm going to use. So cos theta is equal to A over H, which means that theta is equal to cos inverse of A over H, substituting in my values and then using my calculator. My answer needs to be correct to 1 decimal place, so 27.753 will be 27.8. And then that's degrees. Again, worded question, worded answer. So the roof makes an angle of 27.8 degrees with the horizontal, and red box out as my answer.